Hello, once again, guys. Welcome back to my channel, which is at MedZone African Motives. We are still on our revisions, working on our introductions. This is Exponents, all right, our chapter 2 that we're going to focus on. So I'm just going to have a revision. That's why I'm having this part that has got also examples and so forth, because we want to have a recap of what we had in our grade 9 mathematics so that we can be able to understand what you are going to be working with. All right, so this is a revision, laws and definitions. All right, so we saw that from our grade 8, grade 9, we've been talking about a certain situation whereby a number can be raised to a certain exponent. All right, let me just try to reduce a little bit, whereby a number is being raised to a certain exponent. Let us take 2 to the exponent of 3, which is the same as a situation of a letter, which is a variable being raised to the exponent of n. It means that letter is going to multiply itself a number of times, which is this number that we see here. The letter that we see is going to be a times a times a, which are any factors, that is any times. So it is going to be any times. The number that we have here is the one that you're going to use in your multiplication. But what are you multiplying? The base, all right? We are dealing with, remember, A represents the base, N is the exponent, and the whole of this is the power. All right, so that means that 2 to the exponent of 3 is the same as 2 times 2 times 2, or many times 3 times. Going to multiply 2 is going to multiply itself. The number here, the base, it multiplies itself, this number here. So it's going to be 2 times 2 times 2. 2 times 2, which is 4. 4 times 2, which is 8. So that's, we can do that. So on a situation that we're going to have this type of a base raised to a certain exponent, which are the powers, we need to apply the laws. Whenever we work with these numbers or this type of numbers, we need to apply what are referred to as the laws. Remember, from our multiplication, if I am having 2 to the exponent of 2, which is being multiplied to 2 to the exponent of 3 like this. All right. We are simply saying it is a situation whereby I want you to see what is happening. It is a situation whereby 2 is multiplying itself 2 times. We want to go back to the original format, then we go back to the laws, all right? This is the 2 that we are talking about. So this 2 here is going to multiply itself 2 times. So it is going to be given as 2 times 2. It is multiplying itself 2 times, all right? Multiplied 2, we go on to this one that is multiplying itself 3 times. So we are going to have this multiplying itself 3 times, times 2, times 2. That is, we've got this multiplying itself 1, 2, 3 times. The first one, it was multiplying itself 2 times. The second one is multiplying itself 3 times, as we are given here. This is where we're actually supposed to have. Yes, we can multiply whatever that you have, but I want you to see that at this stage, all right, you can multiply and get your 32, which is fine. You can use a calculator, but I want us to talk about this part that is happening here. I want us to finalize here so that we can talk about the laws. How were they created? It is not something to say it's a law because you just have to follow it. No, it's a law because it's something that exists, something that was formulated and seen and proven. So if something is being proven, you call it a law or a theorem, or you can call it a rule, okay? So in this case, we want to prove what exactly is happening here. Let us see. We said if a number is multiplying itself a number of times, we can write that number that is multiplying itself, which is the 2 in this case. to the exponent of the number of times it is multiplying itself. The exponent here is the number of times 2 is multiplying itself. So it is multiplying itself how many times? That's, we're going to count 1, 2, 3, 4, 5. It is multiplying itself 5 times here. So that means we are having 2 to the exponent of 5, which is the same. This gives us a 32. Now let us analyze the 2 to the exponent of 5 from this. Instead, you could have seen that we could have obtained the same 2 to the exponent of 5 that we see here from the laws. It follows that if these bases are the same, right, and you're multiplying and these two are the same and you're multiplying, you simply add the exponents. 2 to the exponent of 2 multiplied to 2 to the exponent of 3 simply means I'm going to add the exponents because the bases are the same, okay? We are talking about 2 and 2 there. They are the same. So you're going to have this as 2 to the exponent of 2 plus 3, which is going to give us 2 to the exponent, all right? Let's just have it down here, which is going to be 2 to the exponent of 2 plus 3, which is a 5. This is the same as the answer that we obtained here, which is the same as this 2 times 2 times 2 times 5 times, which will give us a 32. So as we can see, we are simply talking or referring to the same situation or to the same condition that we're going to get the same answer of 32. So this now brings us to the laws. We have proven that this here that we see, and to expand it, the normal way that we're supposed to do are the same. So that is what we see on our laws. So the first law that we're going to consider is on that part that I'm just explaining, to say that on a condition that your bases are the same, right? We are talking about the powers that are the same, you're going to add the exponents. So a to the exponent of m multiplied to a to the exponent of n, you're going to add your exponents, all right? So meaning to say, on a situation whereby I'm multiplying a certain number like this is, let us just take an example. 2x to the exponent of 4 when being multiplied to 3x. All right, this is what you're going to do. You are going to consider the numbers separated, right? So in actual sense, we are supposed to multiply the numbers separated, right? That means if you multiply this 2 multiplied to 3, you are going to get a 6. Okay, going to multiply this separated, but then you're going to multiply the x and the x separated. So in actual sense, if we are multiplying these x to the exponent of 4, multiplied to x to the x, remember if the exponent is not given, it means to the exponent of a 1. If the exponent is not written, it means to the exponent of a 1. So if we are multiplying, we are back to say whenever these two are the same, a, and we are multiplying, what are we going to do? We are going to add the exponents that we have on these two. That is a to the exponent of m plus n. We add our exponents. So in this case, we are going to add our exponents, which is 4 and 1, because these two are the same. We've got x, we also have x here. So it's going to be x to the exponent. We add these two, that's 4 plus 1. So we are going to obtain 6x to the exponent of 4 plus 1, which is a 5. This is not applying on the numbers 2 and 3. They are not the same. So you just multiply the direct. It only multiplies when the bases are the same. This and this are the same. What you do is you simply add your exponents in that case. You simply add the exponents if you are multiplying. So it's only for a multiplication. So considering that I am having m to the exponent of 7 being multiplied to 7m to the exponent of -3 like this. What it simply means is I'm having the same situation or the same scenario like the previous case. Here, the number that I'm seeing here is same as there's a 1. If the number is not written when you're multiplying, it means there is a 1. So what you're simply doing is multiplying the numbers. You're going to multiply this and you're going to multiply this together. All right? So you multiply the numbers together. So that is 1 is going to multiply 7. That is 1 times 7, which is 7. Then you move on to the m to the exponent of 7, multiplying m to the exponent of negative. So as you can see, these two are the same. So what you do if they are the same and you are multiplying, you're going to add your exponents. So that is going to be m to the exponent of 7. We add, take note, we are adding the other exponent, this one. All right, that is the one that you're going to add, which is a negative 3, like this. So remember our directed number concept from our number line, a plus and a minus combined together, they give us a negative at the end. So this will be a negative. So that will be m to the exponent of 7 minus 3, okay? Plus and minus, that's a minus. And if we simplify this, we are going to obtain 7 minus 3, which is a 4. So that will be 7 m to the exponent of what? Of 4. So this is how the conditions might be on application of this law to say, whenever you're multiplying and you see that these bases are the same, what you're going to do is to simply add the exponents, right? Considering this. So it can be also given in terms of numbers, right? Also, like it can be given just numbers multiplying each other. Maybe it's 2 to the exponent of 2 to the exponent of 7, multiply to 2 to the exponent of 3, multiply to 2 to the exponent of 5. As long these here are the same and you are multiplying in that case, what you simply do is to add everything, all the exponents that you see there. All right, so you're going to add 7 plus 3 plus 5, like this. So that's 7 plus 3, which is a 10, and 10 plus 5, which is a 15. So that will be 2 to the exponent of 15. You can leave your answer like this, or you can simplify. But this one, to multiply 2 15 times, it's a lot of work to do. So what you can do is to simply have your calculator here. Let us see what you're going to have. That's 2 to the exponent here of 15, to the exponent of 15. That will be, we're going to have 32,768, right? So that's 32,768. You separate your values, 3 values like this. Then you just give a space, you write the other 2 values there, okay? So that is the, say it, no, I want this 8, right? I want that value. Here, I want that value. Okay, so that is how we can have this at the end. Instead of you multiplying 2 times 2 times 2, you can just use a calculator when it is like that. All right, so that is how we're going to have a situation of our multiplication. So it is the same thing that you're going to have if you are dividing now. If you're dividing, all right, and these two are the same, that is your bases are the same, or we are working with the powers being the same, because remember we talked about this being a power, the whole of this thing being a power, all right? So as long these two are the same, these bases that we see, a to the exponent a are the same, and you are dividing, you are going to subtract your exponents. All right, but this is provided that your m, this one on top, is greater than n. All right, what are we actually saying if m is greater than m? What are they trying to say here? Because it's one and the same thing, this law, but here, if m is less than. All right, remember, if I'm saying m is greater than n, we are simply saying m is bigger than n. M is bigger than n. So if n is bigger than n, let us take a condition like I'm having 2 to the exponent of 7. Remember, we are divided to 2 to the exponent of 4, like this. Okay? This is a condition whereby this number on top, which is our m, is bigger than this number here. Right, that's an example that you can put there. So we are supposed to subtract, all right, 2 to the exponent of, you subtract, because we said if we are dividing, we are going to subtract our exponents. m minus n. So that is going to be 7 minus 4, like this. We're going to subtract your exponents because you are working with a condition whereby the bases are the same. So what you consider are that these bases are the same. This base here and this base here are the same. So if they are the same, what are we going to do? We are going to consider subtracting our exponents. All right? So you're going to consider subtracting your exponents. So let us subtract. So this will be 7 minus 4, sorry, which is a 3 in that case. Okay? Then you can simplify 2 to the exponent of 3 means 2 times 2 times 2. 2 times 2, okay? Because it's going to multiply 3 times. Okay, that is the one that we have. But it's going to multiply 2 times 2, which is 4. 4 times 2, which is 8. All right, so if you multiply these two, you get a 4. Then 4 times 2, which will give us an 8. If you multiply these two, you're going to get an 8. Or like I said, just use your calculator straightforward. You're going to obtain the same thing. All right, so if you consider this, we consider that m is bigger than n, is greater than, right? Or greater than n. But from the same law that we are talking about here, that we are dividing, let's say this number was smaller. Let's get it as a reverse. Let us just reverse what we get here. 2 to the exponent of 4 this time is supposed to divide 2 to the exponent of 7. So if we check, or if we take a closer look, this is less than this number. It's smaller than 4 is less than 7. All right, 4 compared to 7, it's smaller than 4 is here, 7 is there. So 4 is less than 7. Okay, so if 4 is less than a 7, I want you to see what was supposed to happen. Then I conclude with this law. I'm not using this law so far. All right, I'm not using this law so far. Okay, I'm just going back to the normal law, but I want you to see what was going to happen there. If you're using the normal law, you are going to have this as 2 to the exponent. You subtract your exponents because you are dividing. So that was going to be 4 minus a 7, which is going to give us 2 to the exponent of 4 minus 7. As you can see, we are now subtracting a bigger number from a smaller number. So it gives us a negative. Sorry for that. It's going to give you a negative. Yes, you can simplify 2 to the exponent of negative. So we want to avoid this. How can we avoid this in our syllabus? Yes, it was grade 12, grade 11 is fine. So we want to avoid that scenario of we having a negative answer. So to avoid that, we are going to interchange this m and n. We are going to have n subtracting m, but that we are going to introduce 1 on top. So it's going to be 1 over, you interchange these two, all right? So what am I trying to say? We are seeing that from our law to be, if it is a condition that we are still dividing the same basis, the same, right? A to the exponent of m, a to the exponent of n. But this time, our m is no longer bigger than. Our m is now less than, right? On a condition that m is now less than n. This m, this exponent on top, on the numerator is less than this one in the denominator. So you're simply saying here, m is now is less than, all right? M is less than n. So on a condition like that, we are going to obtain a negative exponent, okay? So you are going to obtain a negative exponent. All right, a negative exponent, since you are subtracting a bigger number, because n is a bigger number, this n. If m is less than n, it means n is bigger than this. So if you subtract a bigger number from a smaller number, you get a negative answer. So that's we're going to have a negative exponent at the end. So to avoid that, that is the condition now. To avoid this, we are going to use this law as 1 over. We want now to avoid this. So we want to avoid having what? A negative exponent. So we are going to have our answer as 1 over. The moment you write 1 over like this, you are now interchanging these two. It was supposed to be, remember, our actual part was supposed to be m minus n, but now you interchange, it will be n minus m. All right, think you get this? So you're going to interchange. The moment you introduce 1 over, you interchange, okay? So what am I trying to say? 2, I'm just going to use the same example here, 2 to the exponent of 4 over, so this time I'm going to use this one on top, this one with the smaller exponent. I'm going to use it on top. This one with the bigger exponent, I'm going to put it down the same way that I did this example, but now we want to avoid this situation of having a negative answer. So if I'm given this as an example, that I have 2 to the exponent of 4 over 2 to the exponent of 7 like this. So if we compare, we can see that 4, which represents m, which is on top, our 4 is smaller than 7, right? Compared to 7, 4 is smaller than 7. So if it is like that, what am I going to do? I'm going to introduce 1 over. So it's going to be 1 over. So my solution here is going to be 1 over. The moment I introduce this division line, like I said, we're going to interchange. So it's going to be this one minus this one. Okay, so do not confuse yourself there, guys. So it's going to be 2 to the exponent of the bigger number minus the smaller number. Okay, so that's 2 to the exponent of 7 minus the smaller number. We have avoided having our answer as a negative exponent, because we know that if we subtract a smaller number from a bigger number, we get a positive, all right? So that will be 2 to the exponent of 7 minus 4, which is 3. But remember, we simplified this before. 2 to the exponent of 3, we got 8. 2 times 2 times 2, 3 times. So our answer now is going to be written as 1 over 8. Okay, so let's say I do not want to use this law. All right, I don't want to consider this to say I'm going to interchange, I'm going to do this. All right, we can have the same answer, guys, that we see here, but now we have to consider this part. We shall talk about it later on here on our definitions of x to the exponent of negative n. This part, it is the one that can now answer that question. Remember, when we subtracted normally, from that example that I erased here, we got 2 to the exponent of negative 3. So we shall talk about that. You'll see that these 2 to the exponent of negative 3 that we got and this answer here are the same. All right. For the meantime, I'm just going to show you on the calculator. But like I said, we are going there, so prove it. All right. So I'm saying 2 to the exponent of negative 3. We are going to have 1 over 8, which is the same answer as this one that we have 1 over 8. So meaning to say the answer that we got there and this one are the same, but we are going to talk about removing that negative, okay? So meaning to say you can choose to maintain your law that if you are dividing, you just subtract your exponents straight, or you can choose this one, or you can, like I said, we're going to talk about the other one in our examples. All right, so that is the condition that you might have on that part. Then if you are multiplying, all right, a condition, sorry, if you are raising, like we've got an exponent, a to the exponent of m, then there's another exponent again, which is outside of the bracket. You simply multiply your exponents together. So if I'm given m to the exponent of 2 being raised to the exponent of 4, there's an exponent, there is another exponent again. So we are saying the whole power, this one, is being raised to an exponent. So what do? You simply multiply your exponents. M times n, that's 2 times 2, 2 times 4, which is going to be 8. So you're going to obtain m to the exponent of what? Of 8. So this is what we also have here. P to the exponent of 3 to the exponent of 2. There's an exponent and there's also an exponent there. So you multiply your exponents together. So it's going to be p to the exponent of 3 times 2, which is a 6. All right. The same, if there are numbers, you do the same thing. Maybe it's 3 to the exponent of 2, raised to the exponent of 3 like that. What you simply do is that there's an exponent and there's another exponent. So I multiply 2 times what? 2 times 3, which is going to be a 6, right? And so I'm having a 3 here. The base here is a 3. So it's going to be 2 times 3, which is a 6. And I can even simplify 3 to the exponent of 6, or I can just leave it like that. It's still one and the same thing. All right, let us just simplify and see. 3 to the exponent of a 6 gives us 729. So this is 729, or you can just leave it like that. Okay, so that is the condition that you're going to have. But this can extend now to say, if you are now having maybe an exponent, just an exponent, but having two terms inside of the exponent, we are going to raise those terms to the exponent of the one that you are given there. All right. So what am I simply saying here is that, okay, I'm going to consider the law for here. I'm going to remove this part. So let us consider this part here. So it simply means if I am having maybe that's x, y like this, it's a product of 2, but they are being raised to the exponent of 4. Every part is going to be raised to the exponent of m. A is going to be raised to the exponent of m, b to the exponent of m. So if I'm given this, it means x is going to be raised to the exponent of 4, y is going to be also raised to the exponent of 4. So I'm going to have this as x to the exponent of 4 times y to the exponent of 4 also. All right, but I want you to see that it can be a condition like this, right? It can be a condition like this one. X being raised to the exponent of 3, y being raised to the exponent of 2 like this, and everything raised to the exponent of 4. Does that mean we are not going to use this law? No, we are going to use it. Here it was just like there's a 1, there's a 1. So we didn't see the effect of that. That is why we're just writing 4 and a 4. But the actual effect was that we were multiplying, we were having something like, in actual sense, this was supposed to be given as x to the exponent of 1 to the exponent of 4 by y to the exponent of 1 to the exponent of 4. This was supposed to be the proper definition. Then we are back here to say, if we are having an exponent and an exponent, you multiply them together. So it's going to be 1 times 4, which is a 4. 1 times 4, which is a 4. But when you are not seeing a number there, just write your answer, right? It's not that much when it is a 1. But now on this person, we cannot close our eyes for this situation. There is no way. We have to apply it. So it means the x to the exponent of 3, this one, is going to be raised to the exponent of 4. So you're going to have x to the exponent of 3 being also raised to the exponent of 4. Y to the exponent of 2 being raised also to the exponent of 4. So you're going to have this y to the exponent of 2 being raised to the exponent of 4 also. So we are back to this part that if a number, a base, is being raised to a certain exponent and also being raised to another exponent, I multiply the exponents. So here I'm going to multiply 3 and 2 and 4. 3 times 4, which is a 12. So that will be x to the exponent of a 12. I do the same thing on this y here, 2 times a 4. So I'm going to obtain y to the exponent of 8. So that is the situation that we are seeing here. All right. Then another extension of the same concept that we are talking about is on this part. If you are dividing also, you're going to apply the same thing. Every number is going to be raised to the exponent of the term that we have outside. So you're going to have a raised to the exponent of m, b also raised to the exponent of m. So this is what we have here. That is, we are simply talking about the same situation as this one. So what it means is that if I'm given variables, maybe I'm given x over y like this to the exponent of 3. Just because it's a 1, it is a 1. So I'm just going to write as it is x being raised to the exponent of 3. Also y being raised to the exponent of 3. All right. But what if there was a certain exponent there? What was I going to do? Let's say there was x to the exponent of 2 over y to the exponent of 3. Then everything being raised to the exponent of a 2. What does it mean? We still have the same situation as this. So it means what it simply represents is that this denominator here is going to be raised to the exponent of 2. Also, this one is going to be raised to the exponent of 2. So it means we are going to have the numerator, this part here, as it is x to the exponent of 2 raised again to the exponent of 2, like this. All right. The same thing on this y here, y to the exponent of 3, also raised to the exponent of 2, because that exponent, it affects everything. But just because there are exponents also inside there. So that's why I'm just opening a bracket. So once you're at this stage, you are now back to our law 3 here. We're now back here because we have a condition of an exponent to the exponent of m, but this whole power is being raised to a certain exponent, which is n. And we said we're going to multiply our exponents if it is like that. So what it simply means is that on top here, I've got an exponent. I'm going to multiply those two. So it's going to be x to the exponent of 2 times 2, which is a 4. All right, doing the same thing, 2 times 3, which is a 6 on this y here, 3 times 2, which is a 6. So that will be y to the exponent of a 6. Okay, so that is how we can simply answer this question. As long what we have here is everything raised to a certain exponent, you use that exponent to affect each and everything that you have, whether it's on a multiplication like what we saw here, all right, whether it's on this multiplication part or it's on this division. We have the same thing on multiplication and on division. So these laws, they are or they can be used whenever this is applicable. Whenever any of this is applicable, you can use your laws. All right, then we have got a condition of our definitions, like I said, the ones that we once had or even talked about from our grade 9. All right, we know that every number is being raised to the exponent. This is a revision, I think, from grade 8. Yeah, from our grade 8 there. Any term that can be raised to the exponent of a 0, it gives us what? A 1. Which is actually true that it gives us a 1. But do not forget that we are simplifying. All right, let me just remove this part, guys. All right, that's 1 there. So we are still on 1. So, but do not forget this condition here that I want you to understand that it's true. We are saying if I see any term being raised to the exponent of a 0, it's going to give me a 1. Very, very true. But let us consider a situation like this, whereby I have a number which is 5 and x raised to the exponent of 0 like this. Do not be tempted to say your answer there is a 1. The answer is no longer a 1 at the end, because we consider, yes, it's true that x to the exponent of 0, it gives us a 1. This is for x to the exponent, this one. It is the one that is going to give us a 1. But are you considering that there is a 5 which is multiplying here? Is not affected by the exponent. The exponent is not on 5. It is on x. So this means we are going to have it as 5 multiplied to x to the exponent. That we can properly see that this here, it gives us what? A 1. Any number raised to the exponent of 0, it gives us a 1. So now we can properly see the separate of this. So it's going to be 5 times 1. And if we multiply 5 times 1, what are we going to get? We are going to get a 5. So you have to be careful when it is like that. It's different from this. Do not confuse again on this one. 5x to the exponent of 0 like this in a bracket like this. What does it mean here? All right, this one, everything is being raised to everything. So we get a 1. But how can we prove so? All right, let us go back to our laws. 5x to the exponent of 5x, everything to the exponent of 0 like that. Remember what we said about a term when if you are multiplying or what being raised to a certain exponent, everything is going to be affected by the same exponent, everything inside of the bracket. So here inside of our bracket, we have got 5x being raised to the exponent of 0. So it means 5 is going to be raised to the exponent of a 0. X also is going to be raised to the exponent of 0 if it is like this. So that means we are going to have 5 to the exponent of a 0, which is 1, times x to the exponent of it, which is a 1, because any number to the exponent of a 0 is a 1. Then we can multiply 1 times 1, which is what? Which is a 1. So that is, we can have the same answer like this one. But consider, because everything was raised to the exponent of a 1, which is different from this one. Here it is 5, which was being raised to the exponent of a 1. Here it's every term that is being raised to the exponent of a 0. Right? It is only x which was raised to the exponent of a 0, sorry. And also here, and also on this part, it's everything that is being raised to the exponent of a 0. So our answers, they're going to be different, the presentation, but we have to consider that this does not change that if a number is raised to the exponent of a 0, it's a 1. But there's a number that is there that you need to multiply to. So that is what I'm trying to say on this part. All right. So let us consider another part of our definitions. Raising a number to a negative exponent as what we see here. We are going to write it as 1 over. To remove this exponent negative, to remove the negative, we're going to write it as 1 over, just to remove this exponent. So it means if I'm given this, guys, we are saying, if I'm having x to the exponent of a negative n like this, we are going to have it as 1 over x to the exponent of n. So to just remove a negative here, you write it as 1 over. So the moment you write as 1 over like this, you have removed the negative. So it means we are left with what? X to the exponent of n, which is the one that we see here, because we have removed the negative. So our answer cannot carry a negative. So you have to remove the negative, because they will ask you to write your answer as positive exponents. So you'll be forced now to change that. Like for an example, let us say we have got our answer as 2 to the exponent of negative 3, like that one that we simplified before. So we're going to see this is going to give us 1 over, because there is a negative. So I want to remove that negative there. So to remove this negative, I'm going to write it as 1 over. I have removed it. So I'm going to remain with what? 2 to the exponent of 3. So it will be 2 to the exponent of 3, which we can simplify 1 over 2 to the exponent of 3. We talked about this number before, guys. We saw that we are going to get an 8. So it will be 1 over 8. So it can be for variables, it can be for the normal terms, whatever that you're given, all right? 3, which is the same thing that we have here, but this time there's a number that is multiplying. You're going to have it as a over x to the exponent of n if there's a number that is multiplying, meaning to say if I'm given 3x to the exponent of negative 5 like this is going to be 3. It's a number. 3 is not affected by a negative, so it's going to remain on top, which is our a, in this case, over x to the exponent of 5. Okay, so this simply means that even if you go back to this first law, you can even answer this question. 3x to the exponent of negative 5. It simply means I'm multiplying two terms here. 3 times x to the exponent of negative 5. So you can see that 3 is not affected by a negative. It is x which is affected. So this means I'm going to have 3 multiplied to Remember, how do you remove a negative exponent? We said we write it as 1 over. So it is going to be 1 over x to the exponent of a positive, because we have removed this negative. It's no longer there. So it is going to remain as a positive exponent, all right? So here it simply means you're multiplying. So this is same as 3 over 1. Remember, every whole number as a fraction is over 1, so that we can properly multiply 3 times 1, the numerator to the numerator together, all right? That will be a 3 over 1 times x to the exponent of 5. Remember, anything multiplied by 1 does not change. So it's going to remain as x to the exponent of 5. So this is what we are explaining from a definition. So yes, you cannot see that. You can use the longer way like this. You still have the same answer, or you can apply your definitions. So that is the advantage. It's like the laws. You, instead of you multiplying 2 to the exponent of 3 times 2 to the x, instead of you multiplying 1, 1, 1, 1, you can just use a law. So that's what we are saying, to say some of these you can go back to the original way of attempting them, or you can just apply one of the laws that you understand about that. Still, it gives you one and the same thing. All right, so it is the same thing again. At this time, we are having the whole of our expression being raised to the exponent of a negative inside a bracket. Let's say we've got a 2x to the exponent of negative 3. Everything is raised to the exponent of a negative. So we are seeing that this is going to give us 1 over everything inside, because the whole of the bracket, guys, is being affected. The bracket is affected. All right, so it's going to be 1 over everything inside this bracket. All right, being raised now to an exponent of a positive, because we have removed this negative by 1 over. So it's now exponent of 3. But we can simplify. Remember, we said if a bracket, if you're having a bracket raised to a certain exponent, it means everything will be raised to that exponent. All right, from this one here, still remember from this one. Okay, from our 4 here, talked about this. So it means we are going to raise everything this time to the exponent of 3. So it's going to be 1 over 2 raised to the exponent of 3. So it will be 2 to the exponent of 3, x also to the exponent of 3. Okay, we're going to simplify. We are still with our 1 over. We are still writing down, all right? So it's going to be 1 over again, 2 to the exponent of 3. We saw this one before. That's an 8. So that will be 1 over 8x to the exponent of 3. This is in simplest form. In simplest form. Okay, so that is how we can get rid of our negative exponents if it is like that. Okay, which is the same scenario or the same situation. Number 5, 1 over x to the exponent of negative n means x to the exponent of n. What does that mean? If I'm given, I can have a situation where I'm having a negative. Remember, we were having 1 over x to the exponent of n. It was positive n. Now we can have a situation where this term, it is carrying a negative. So in actual sense, this is what was supposed to happen. We are supposed to have it as 1 over. Remember, we said to remove a negative on x to the exponent of negative n. To remove this negative here, we write it as 1 over. So we are supposed to have it as 1 over again, x to the exponent of n, like this. All right. But if you go back to algebra, we talked to the introduction of algebra, we talked about the issue of our numbers, the reciprocal of a number, to say 1 over a fraction like this means the reciprocal, the inverse of. So is the inverse of this. And the inverse means you simply interchange these two. That's the inverse. 1 over a certain number means the inverse. So it simply means I'm going to have x to the exponent of n over 1. And remember also from our laws, if you divide by 1, that term remains as it is, or the number remains as it is. So we can see that it is something that is being proven, that this whole part here is equal to x to the exponent of n. But this is exactly where it was being taken from. These were the steps that we're supposed to take. But as for you guys, they just want you to know your definitions. Just know that if you've got a negative, you're going to write it here as a positive without 1 over. So it will be just x to the exponent of n. For an example, if I'm given 1 over 3 to the exponent of negative 3, because I'm having 1 over already, so it is just going to be 3 to the exponent of positive 3 without a negative. All right, that is what it means. So meaning to say I'm going to have 3 raised to the exponent of 3 means 3 is going to multiply itself 3 times, which is the exponent. So that will be 3 times 3 times 3, which is 27. 3 times 3, that's 9. 9 times 3, which is a 27, right? Or you can just use your calculator when you're at that stage. So this is how it can go. This is how it can go. Whether it's a variable that I'm having here, whether I'm having 1 over, let us just take a consideration of having 1 over x to the exponent of negative 4 like this. One and the same situation that I'm going to apply. So what am I going to have here? Because I'm having 1 over, and this is raised to a negative exponent, I'm just going to take what is remaining as a positive, all right? So it's going to be x to the exponent of 4 as a positive. I'm done. That's the advantage of knowing your definitions. But like I said, even if you do not understand your definitions properly, you can still go back and apply your normal simplification. Still, you get the same answers on whatever that should be simplified. So these are the typical questions that we might be given in our simplification. So we had an introduction, guys. We had an introduction of everything, talked about our simplification. So we want to see how our questions might be given as, and I would like you guys to work on more questions because as you can see, there are so many questions there. So many questions that you can be able to consider or to work with. But I want you to do as much questions as you can. But if there's a question that we see on this exercise that is having a challenge, let me know so that we can work on these questions, right? Let me know about that so that we can work on those questions together on a separate class. But what I want you to do is to try as much as you can, all right? We talked about almost everything, like everything that we have here, everything, okay? So just go through this exercise. All right, on question number 1, we are given 2p to the exponent of 0. All right, so this simply means we can see that what is being raised to the exponent of 0 is p. So we can separate that as a multiplication to say this is same as 2 by p to the exponent of 0 like this, which is 2 times 2p to the exponent of 0. We know that any number to the exponent of 0 from our definitions gives us a 1. So that's 2 times 1, which is going to give us a 2, okay? Which I also explained when it is like this from our examples. Remember, we saw this. When the whole bracket is being raised to the exponent of 0 like this, we are going to get a 1, okay? The whole of the bracket is being raised to the exponent of 0. It gives us a 1, which I also explained from AX. If we are given a product, right? Let us just say for AB being raised to the exponent of m, we're going to have A to the exponent of m and also B to the exponent of m. So we can also prove it that way. If we do not understand this, then we can also prove that way. So you're going to have 2 raised to the exponent of 0, p to the exponent of 0 in that case. So that will be 2 to the exponent of 0, p to the exponent of 0 like this. So this will be 2 to the exponent of 0 means a 1. Remember, any number to the exponent of 0 is a 1. All right, times p to the exponent of 0, which is also a 1. 1 times 1, that's a 1. So meaning to say, we still have the same thing as from our laws and from our definitions. So I want you guys to go through these questions. I'm not going to answer them. Like I said, go through them. But if there's a question that you see having a challenge, let's mention them down on the comment section so that we can work with those questions. As you can see, this is a lot of an exercise, so many questions to consider or so many questions to work with. So let me know about these questions so that we can work on them. For a condition that you still have challenges on any of these, let me know, guys. All right. Then maybe just a smaller part about these negative exponents that you see here. Remember from your grade 9, we talked about the issue of exponents. All right, let me just write it even this side. We talked about issue of negative numbers raised to exponents. It can be a negative, it can be a negative being raised to an even exponent. Like for an example, I've got negative a raised to an even number. In this case, this exponent is an even number. Okay, let me just write even. Okay, what we are going to have in that case is going to be a positive. And negative, when raised to an even number, it gives us a positive. So our answer will be a positive, a to the exponent of that same even number. All right, what am I trying to say? Negative 2 raised to the exponent of a 4. We're talking about an even number there. So we're talking about even numbers, 2, 4, 6, and so for multiples of what? 2. All right, 2, 4, 6, and so on. So I see that 4 is an even number. So that means the negative, when being raised to this, it becomes a positive. So our answer definitely is going to be a positive. All right. Then 2 is going to be raised to the even number that we see there. 2 is not just going to remain as 2. It will be raised to that same number. But here we are now having a positive. All right. So our answer is going to be 2 to the exponent of 4. Remember, I said it multiplies itself 4 times. All right. Or you can just use your calculator like that. Or you can multiply this 4 times. 2 times 2 times 2 times 2 4 times. That's 1, 2, 3, 4. So if we do this, what are we going to have at the end? We're going to obtain 16. 2 times 2, that's a 4. 4 times 2, that's an 8. 8 times 2, which is a 16. All right, so we can also prove that on our calculator. Is it true about these definitions that we see here? All right, let us save this. Negative 2 to the exponent of this 4. All right, that's positive 16. That's when raised to an even exponent, it becomes a positive. But what if it was raised to an odd number, which is not an even number, right? So we are having now negative a, all right, negative a being raised to an odd number, which are odd numbers. Those numbers that when you divide by 2, they will give you a remainder of 1. So in that case, it is going to remain as a negative. All right? And a will be raised to the exponent of that odd number. What does that mean? Take a consideration of having negative 2 being raised to an odd number. A number that you can divide by 2 gives you a remainder of a 1. Take a closer look of 3. So this is an odd number here. So the answer is going to remain as a negative. All right, from our definition, going to have a negative. But 2, which is a, must be raised to that exponent, which is the odd number. So it's going to be 2 to the exponent of 3. That one is not going to change. So our answer is going to carry a negative as it is. So that's negative 2 to the exponent of 3, which gives us 8. So our answer is going to be a negative 8. So you can prove that also on your calculator. Like I said, let us go to our calculator. You're going to have a bracket, negative 2 in a bracket. You have to open the bracket there. Raise it to the exponent of 3. So this will give us a negative and negative 8 to show that we are simply referring to one and the same thing. So I want you to do now as a practice, as an exercise, perform these calculations and see if you are winning. If not, let me know so that we can work on this section once again on our revisions so that you can properly understand what exactly I was trying to say. But we shall work with more questions, more revisions, and more exercises to come as we are preparing ourselves on this topic. So just go through the introduction part, go through your laws and rules, whatever that you have, your definitions, whatever that you're gonna have from your grade 9. Those notes that you were using in grade 9, don't throw them away. They are still very, very applicable on your exponents. They play a major role on your exponents. So go through those notes first and also add this information that we talked about. Then we shall see each other in our next class.